Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic we are going to discuss the normalizing of a two-dimensional vector. So in this topic we will introduce the concept of normalizing a vector, that is, dividing a vector by its two norm. We will see that this produces a unit vector. We'll look at some examples and see an observation. Recall that the two norm of a vector is its length. So given this vector here, we can calculate its length by taking the square root of the sum of the squares of the two entries. So for example, given this vector here, we see that its two norm or length is approximately 1.4422. Now, recall that the two norm of a vector is 0 if and only if the vector is equal to 0. All other vectors will have a two norm that is strictly greater than 0. Recall also that a unit vector is any vector that has a two norm equal to 1, and all unit vectors lie on the unit circle. So here are 4 examples of unit vectors lying on the unit circle. So, therefore, let's introduce this topic. Given a non-zero vector u, let us calculate a new vector, and we will show its relationship to u by putting a small cap on top. So u cap is by definition the reciprocal of the norm times u. And we will sometimes just write this as u over its two norm. So recall that the two norm of any non-zero vector is a scalar. It's a real number. Therefore, 1 over the two norm is also guaranteed to be defined and must also be real. Consequently, all we are doing to get the normalized vector is multiplying a vector by a scalar. So this is just scalar multiplication, which we've just seen. It happens that the scalar is the reciprocal of the two norm of the vector. We call this process normalization. Let's calculate this explicitly. So here we have multiplied the vector u by the reciprocal of the two norm. So let's calculate the two norm of u cap. Well, the two norm of u cap is the square root of the sum of the squares of the two entries. Well, wait a second. The square of a ratio is the ratio of the squares, and the square of a square root is just the absolute value of what is being square rooted. However, the contents of the square root is guaranteed to be positive. So we're just left with this. And we already have a common denominator, so let us use that. But wait a second, that's just equal to the square root of 1, and that's equal to 1. So therefore, we are guaranteed that as long as u is not the zero vector, u cap is indeed a unit vector. Let's look at some examples. Here we see a vector u equals 3, negative 4. Well, the square root of 3 squared plus negative 4 all squared is just the square root of 25, which is 5. So dividing both 3 and negative 4 by 5 gives us the vector 0.6, negative 0.8. And if you tried calculating the two norm of u cap, you will see that yes, indeed, it is a unit vector. If I have the vector negative 12, negative 5, well, you may remember that 12 squared plus 5 squared is 169. The square root of 169 is 13. So if we divide both entries by 13, we get the vector we see here, and that vector also has unit length. Given the vector w here, we can approximate its its normalized vector by dividing both the first and second entries by the 2 norm of that vector, yielding the vector we see there. But again, this is only an approximation. Geometrically speaking, here we see 4 two-dimensional vectors. If I was to divide each of these by its 2 norm, we would get the corresponding unit vectors, which, as you can see, point in the same direction as the original vectors. Also, given a vector u, we will notice that u is equal to its corresponding unit vector or normalized vector multiplied by the 2 norm of u. And again, as I just said, if vectors are considered arrows, the normalized vector points in the same direction as u. So u cap points in the same direction as u. Okay. So in this topic, we've introduced the normalizing of a vector. That is, we divide a vector by its 2 norm to give a resulting vector that has unit length. This process is called normalization. So given any non-zero vector u, we can produce its corresponding unit vector u cap by dividing u by its 2 norm. This is simply an application of scalar multiplication because the 2 norm is a real number. If the real number is positive, its reciprocal is also a real number, and so we are simply multiplying a vector by exactly that scalar such that the resulting scalar multiple of the vector has length 1. The corresponding normalized vector points in the same direction as the original vector if you consider vectors to be arrows. Here are some references: Acknowledgments, the colophon, and a disclaimer. Cheers!